So solving equations, specifically polynomial equations. By factoring. There are other ways to solve some polynomial equations, which we will get to in the next couple weeks. However, solving by factoring is always the simplest and leaves the least amount of room for error. Like, people really like the quadratic formula, but in reality, like, it's so easy to mess it up, like when you do the calculations to simplify the quadratic formula. Whereas when you get pretty proficient at factoring, like, it's pretty quick and you usually don't make calculation errors. Also, factoring just has a lot more applications. So, like, knowing how to factor is more valuable than knowing the quadratic formula, because the quadratic formula does, like, one thing for us and one thing only. Like, we can't apply it to anything else. So we always talk about solving by factoring first, just because it's the most kind of efficient and leaves the least amount of room for error than the other methods. So when we solve linear equations, which are kind of the only equations we've solved so far, well, so, like, even if we had more than one term that contained a variable, because it's a linear equation, that means that it's a degree 1 polynomial equation. All of the terms that contain a variable are like terms, which means you can always combine in order to get a single term containing a variable and a single term not containing a variable, because even if we had terms containing x on the other side, we could subtract it, combine like terms, and so we can always put it in the form of a single variable or a single term on the left that contains a variable and a single term on the right that doesn't contain a variable, which allows us to get our variable alone just by division. So when we solve linear equations, we isolate the variable, is what that's called, is when you get a single. Okay, so back to this guy. So I always ask myself those two questions. Do I have a 0 on one side? Do I have a product on the other? Always get the 0 first, because if you get the product first and then you subtract to get a 0, you're going to have to refactor the other side again. So, do I have a 0 on one side here? I don't, but I can get one just by subtracting 6 from both sides. So we have x squared minus x minus 6 equals 0. And then, do I have a product on the left side? We don't, right? The main operation going on between the objects in that polynomial is subtraction, right? There's nothing being multiplied there except the multiplication within the terms. Like, that first term is x times x, so there's some multiplication there, but it's within individual terms. So the operation, the main operation going on is subtraction. So in order for me to solve this using the zero product property, I need to factor, which you guys already did. So I'm going to replace x squared minus x minus 6 with x plus 2 times x minus 3. And if we hadn't already factored this, we would just go through the factoring process at this point until we got the factored form on the left. I just thought if we did all that first, it would save us a little time in solving. So now we have a product on the left, we have a 0 on the right, so I'm going to set each of my factors equal to 0. And solve. So I have x equals negative 2 and x equals 3 are my solutions. So far, so good? Okay, let's do some more. Okay, you guys try solving this one, see what happens. We don't have to worry about it. So we got a 0 on one side. And then we factor out a 5b. I guess we didn't really have to do that one ahead of time. And then, how many factors are there here? So basically there's 2. There's actually 3, but we'll see in a second that we usually think of it as 2. So the 3 things being multiplied here are 5b and b minus 2, right? That 5b is also multiplication. So technically speaking, we have a factor of 5, a factor of b, whoops, and a factor of b minus 2. But 5 is never going to be equal to 0, right? If we have a constant factor, it's never going to give us a solution. So it's kind of convention to, just as you guys did, to think of this as 2 factors. So whenever we have a GCF, no matter how many factors it contains itself, we can think of it as just one single factor and set it equal to 0. So that gives us b equals 0 and b equals 2. And if your GCF is just a constant, so if it doesn't have a variable at all, then you can just disregard it. So if we had like just factored out like a 3 and had like 3 times x plus 5 or something like that, we can disregard the 3 because it's not going to tell us anything about our solutions. Okay, let's solve. So I want a 0 on one side. I'm going to subtract 30x from both sides. And remember, when we factor, we like that first term to be positive. And so you can get 0 on either side of the equation. But I always choose to do it in such a way that that stays positive. So in this case, I subtract 30x from both sides. So we have 3x to the third minus 9x squared minus 30x equals 0. And you guys factored this for me, 3x. So this factored as 3x times x minus 5 times x plus 2. I just got that from the list we made at the beginning. Notice that in every step I'm writing an equals 0, so it's easy to lose that equals 0 because it's kind of redundant. You write it in every step. But just like when we solve linear equations, you want every step to be an equation because it's really easy to mix up problems like we've been doing the past couple days where we're not solving, we're just factoring, and problems where we actually have to solve an equation if you lose that equals 0 somewhere along the way, especially on a test when you're in a hurry. So you don't want to, again, those symbols help us differentiate between like what type of problem we're doing so that we know what to do. So every step should be an equation. So we have 3x equals 0, x minus 5 equals 0, and then x plus 2 equals 0. That was not appropriate language. I wonder what they're doing. X equals 0, x equals 5, and x equals negative 2. So like this is a good example of when we couldn't solve using the quadratic formula. Like once we factored out the 3x, we could have solved just the part in parentheses, but then we'd lose that x equals 0 if we didn't account for it earlier. So it's like if you're going to start factoring, you might as well finish, you know. Questions on this one? So we did this one too. Oops. squared minus 2 times x plus 1 to the third equals 0. Is that left side a product? It's not, right? I mean, it's tempting because sometimes when we see the parentheses, we think, oh yeah, this is factored. But remember that because there's subtraction here outside of the parentheses, the whole thing isn't written as something times something else times something else. So we have to go a little further, which we already did earlier. We factored out an x plus 2 squared and had negative 2x plus 3 equals 0. How many? Oh, I'm sorry. Thank you. How many factors do we have here? 2/3. So both, I mean, again, just like the last one, like both are kind of correct. So x plus 1 squared is technically x plus 1 times x plus 1. But setting both of those equal to 0 is going to give me the same solution. So it's like sort of silly to do it as two separate factors. So we just say that x plus 1 squared is equal to 0. And what's the only thing you can square to get 0? 0. So this means that x plus 1 is equal to 0. So we really didn't need that squared at all. And then our other factor, negative 2x plus 3 equals 0. So we get x equals negative 1 and x equals 3/2. Because subtracting 3 gives us negative 3 and divided by negative 2 gives us a positive. So one of the cool things about polynomials is like the degree of the polynomial tells you the maximum number of solutions you can have. So like notice that first one here is degree 2, we got 2 solutions. The second one's degree 3, we got 3 solutions. This last one is degree 3 because if you multiply all that out, the highest exponent you're going to have is 3. And we only got 2 solutions. But technically speaking, we got 3, right? Because we had 2 factors of x plus 1. So if you get if the number of solutions is less than the degree, it's either because 1 or more of them or 2 or more of them are complex or because they're repeated. But if you think that you got 4 solutions to a degree 3 polynomial equation, that would be an indication you should go back and check that you didn't make a mistake because the degree is the maximum number of solutions you'll get that's possible. And then the other type of thing that you're going to see on the homework tonight is problems that like we've done before. And then the only difference between what we've done before and what we're doing tonight is that you end up solving a quadratic equation instead of solving a linear equation. But the overall problem is the same type of thing. So like when we find domains, even though we're finding domains again, we're not changing how we find domains. It just turns out that we have to solve a quadratic to find the domain instead of a linear equation. So for example, if I want to find the domain of f of x equals x minus 2 over 2x squared plus 4x minus 30. So how do we find the domain of this type of function, of a function that has a fraction in it? Not equal to 0, right? So we solve it just like an equation, like they're equal. But remember, we can't divide by 0 is the only operation we can't do in this equation, or in this expression. So we just take the entire denominator and set it not equal to 0. And again, like we're going to solve this exactly like the equation equals 0. We're just using that not equal to remind ourselves that we're finding things that are not in the domain as opposed to finding things that are in the domain. So you guys already factored this guy. It was 2 times x plus 5 times x minus 2, 3. No, it was 3. Sorry, I'm trying to remember what we did. There we go. So then notice that our GCF in this case is constant, right? It's just a 2. Well, 2 is never going to be equal to 0, so we don't have to worry about it. Again, like if your GCF is a constant, it's not going to contribute anything to your solutions. So we only have to take our 2 factors, x plus 5 and x minus 3. So x cannot be equal to negative 5, and x cannot be equal to 3. So if we look at that on the number line, we have our negative 5 here, we have our 3 here, and this is really similar to what we did when we found domains before, but before we had usually just one excluded value, so one number that x couldn't be. In this case, x can be anything that's less than negative 5, it can be anything between negative 5 and 3, and it can be anything greater than 3, so we're going to have 3 separate intervals instead of 2. So we'll go up to negative 5, then start up again, go up to 3, start up again, and then go up to infinity. So we could do this like as many times as we wanted. Like if we happen to find like 20 numbers that couldn't be in the domain, that would just give us more intervals. We'd have everything up to the lowest one, each interval between them, and then everything above the highest one. So in this case, we're going to have 3 intervals. So negative infinity up to negative 5. We're not including negative 5 because x's can't be equal to negative 5. And then anything between negative 5 and 3. And then anything above 3. So that's going to be our domain. Make sense? The other type of question that you will see on your homework tonight are like those application problems where you're given an equation. I'm not going to write out this whole paragraph because I feel like that'll take up 7 minutes in and of itself. But like we have a problem here where like the height of a t-shirt that shot out of a t-shirt gun at intermission is given by this equation. And we can ask a question like if, like how long was it in the air? Before being caught by a fan seated like 440 feet above ground level. So again, this is similar to the types of problems that we've already solved, right, where they give us a function and then they give us either an input or an output. The difference is just that we have a quadratic to solve instead of a linear equation. So do they give us the input or the output here? They give us the output because they're giving us the height, right? And so that means that we're going to replace the entire left side of the equation with 440, right? Which is different. If we put 440 in, like if we did h of 440, that would be saying that 440 seconds have passed, which isn't the case, right? So we're going to solve 440 equals negative 16t squared plus 96t. plus 880. So just like we've been doing, we want to start by getting a 0 on one side. So we'll subtract 440 from both sides, and we get 0 equals negative 16t squared plus 96t plus 440. And if you... Right, but I subtracted it from 880. It's a little tricky because they're the same. If you really like your 0 on the right side, like some people just really don't like their 0 on the left, you can, like, after you do that, you can move it over here, and it doesn't change anything, like swapping sides like that. As long as it's an equation and not an inequality, you can swap sides all you want. So then we would factor, is 440 divisible by 16? No, so it definitely is divisible by 8, though. So I'm going to factor out a negative 8, right? Yeah, it is. And I get 2t squared, and then minus 12t. Notice that all the signs are changing because I'm factoring out a negative. And so this is 555. And from there, you would solve for t. I'm not going to do it because I discovered in my last class that I think that this doesn't actually factor. Like, I made a mistake when I was making up the problem. I remember, like, getting the numbers to work. Like, I wrote it down on a piece of paper, and I think I didn't actually change them. Like, go back and change them in the document. And we don't have enough time for me to check. But we would just continue factoring, solve for t, and then that would give us the time. In this case, one of our solutions would be negative and one would be positive, but time doesn't go in the negative direction, right? So we would just use the positive and say it was in the air that long. So again, similar problems to ones we've done before. The only difference is that we're ending up with quadratic equations instead of linear ones. So try not to like think of it as a completely different problem and then like worry about how to do them differently. It's really just the same thing. We're just adding a little one level to it by changing the type of equation.